Can a trigonometric identity decide the possible values of lambda? Let us crack this. If the equation cos⁴θ plus sin⁴θ plus lambda is equal to 0 has real solutions for theta, then lambda lies in the interval. We have four options. Let us consider the given expression, that is cos⁴θ plus sin⁴θ plus lambda is equal to 0. We can rewrite this as cos⁴θ whole square plus sin⁴θ whole square plus lambda is equal to 0. Because we are using the identity of a plus b whole square equals a square plus b square plus 2ab. That is a square plus b square whole square is a to the power of 4 plus 2a square b square plus b to the power of 4 here. This we can rewrite it as a square plus b square whole square minus 2a square b square is equal to a to the power of 4 plus b to the power of 4. Therefore, a to the power of 4 plus b to the power of 4 can be written as a square plus b square whole square minus 2a square b square. Here we have cos to the power of 4 theta plus sin to the power of 4 theta. This can be written as sin⁴θ plus cos⁴θ whole square. Here a square is cos⁴θ and b square is sin⁴θ. Minus 2a square b square means 2 sin⁴θ cos⁴θ plus lambda equals 0. Therefore, the given expression is reduced to sin square plus cos square minus 2 sin square cos square plus lambda is equal to 0. We know that sin⁴θ plus cos⁴θ is 1. Therefore, we have 1 minus 2 sin⁴θ cos⁴θ plus lambda is equal to 0. Let us divide this second term by 2 and multiply by 2. Therefore, this can be rewritten as 1 minus 4 sin⁴θ cos⁴θ divided by 2 plus lambda is equal to 0. This 4 sin⁴θ cos⁴θ is nothing but 2 sin theta cos theta whole square, which is nothing but sin 2 theta whole square. Therefore, given expression is reduced to 1 minus sin 2 theta whole square by 2 plus lambda equals 0. Let us solve for lambda. Lambda is equal to sin square 2 theta divided by 2 minus 1. When sin 2 theta equals 0, when you give value for sin 2 theta, that is if sin 2 theta equals 0, then lambda will be here 0 minus 1, that is 0 minus 1, which is minus 1. If sin 2 theta equals 1, then we have 1 by 2 minus 1. Therefore, lambda belong to this closed interval minus 1 to minus 1 by 2, that is 0 minus 1. Here it is minus 1 and of minus 1 is minus 1 by 2. Because sin⁴θ lies between 0 to 1, we have lambda belong to minus 1 to minus 1 by 2 closed interval. So let us look at the options. We have option D, which contains this answer, that is minus 1 to minus 1 by 2. If you enjoy solving tricky identities like this, hit the like button and subscribe for daily JEE and Karnataka CET math drills. Don't forget to share with your study groups. Thank you.